Sorry, guys, where were we? I was getting ravaged by my savage for some more child support or something. Oh, yes, relativity. Let's see, we were at the second part. The factor is generally represented by the Greek letter beta, okay, and is determined by the velocity of an object in accordance with the following equation. In which b is the velocity of the object and c is the velocity of light. The beta factor does not differ essentially from unit for any velocity which is ordinarily encountered. The highest velocity encountered in ordinary ballistics, for example, is about 1 mile per second. A mile per second. This must be old. The highest velocity attainable by a rocket propelled by ordinary chemicals is a few miles per second. The velocity of the Earth as it moves around the Sun is about 18 miles per second. At the last named speed, the value of beta differs from unity by only 5 billionths. Thus, the ordinary terrestrial phenomena, the relativism corrections, are of little importance. Right. Fine details don't matter because relativity really doesn't matter. It's all relative. Oh, it's not? Okay, whatever. Right. However, when velocities are very large, as is sometimes the case in astronomical phenomena, wow, stuff we don't have to worry about for the most part, right? Relativistic corrections become significant. So if you multiply the small little fucking fuse by a lot, or you multiply the big bang, and the fuse stays the same small length, right? Those factors are important, right? Well, bless you. Similarly, relativity is important in calculations of very large distances or very large aggregations of matter, as the quantum theory QE. We didn't do that one, we did mechanics. Okay, we'll go into theory next. Applies to very small, so the relativity theory applies to the very large, right? So John Deere, the tractor people, right? They used to go door to door to farmers everywhere, here and there, right? And they used to have a tractor. One of their John Deere tractors, about yay big, right? And they would go door to door and they would put the little gasoline in it and they would turn it on and it would run. A little motherfucking metal tractor running, right? And they said, you can buy this a bunch of sizes bigger. Fucking, that's how you sell something. Right. Until 1887, no flaw had appeared in the rapidly developing body of classical physics. In that year, the Michelson-Morley experiment, see interferometer was performed. We will interferometer in an attempt to determine the rate of the motion of the Earth through the ether. Ether, right? If the Sun is in absolute rest in space, then the Earth must have a constant velocity of 18 miles per second caused by its revolutions about the Sun. if the sun and the entire solar system are moving through space, however, the constantly changing direction of the Earth's orbital velocity will cause this factor of 18 miles per second to be added to the sun's velocity at certain times of the year and subtracted from it at others. The result of the experiment was entirely unexpected and inexplicable, right? The apparent velocity of the Earth through space was zero at all times of the year. Because he ain't relative enough. What the Michelson-Morley experiment actually measured was the velocity of light through space in two different directions. Right? If a ray of light is moving through space at 186,296 miles per second, although this says just 186,000 miles per second, right? And an observer is moving in the same direction at 18 miles per second, then the light should move past him at a rate of 18,509,000 or 185,982 miles per second. Well, actually, we'll find out how fast light goes when we get to light. That's a good part of this, right? If the observer is moving in the opposite direction, the light should move past him at 186,018 miles per second. No way. No way, right? It was this difference that Michelson-Morley experiment failed to detect. The failure could not be explained on the hypothesis that the passage of light is not affected by the Earth's motion, because such an effect had been observed in the phenomena of the aberration QV of light, right? Apparition, whatever. In the 1890s, Fitzgerald and Lawrence advanced the hypothesis that when any object moves through space, the direction of its motion is altered by the factor beta. The negative result of the Michelson-Morley experiment was explained by the assumption that the light actually traversed a shorter distance in the same time, i.e. moved more slowly, but that this effect was masked because the distance was measured of necessity by some mechanical device which also underwent the same shortening. Just as when an object 2 feet long is measured with a 3-foot tape measure, which is shrunk to 2 feet, the object will appear to be 3 feet in length. Thus, in Michelson-Morley's experiment, the distance which light traveled in 1 second appeared to be 186,000 miles, regardless of how fast light actually traveled. Wow. The Lawrence-Fitzgerald contradiction was considered by scientists to be an unsatisfactory hypothesis because it could not be applied to any problem in which measurements of absolute motion could be made. In 1905, Einstein published the first of two important papers on the theory of relativity. Here we go again, fucking over 100 years old, this fucking retard. In which he dismissed the problem of absolute motion by denying its existence. Okay. According to Einstein, no particular object in the universe is suitable as an absolute frame of reference which is at rest with respect to space. Any object such as the center of the solar system is a suitable frame of reference, and the motion of any object can be referred to that frame. Thus it is past the station, or that station moves past the train. This example is not as unreasonable as it seems at first sight, for the station is also moving due to the motion of the Earth on its axis and its revolution around the sun. All motion is relative according to Einstein. None of Einstein's basic assumptions were revolutionary. Newton had previously stated that absolute rest cannot be determined from the position of bodies in our regions. Wow. So, yeah, he said it's not new. Wow, so he said something not new that people should have knew. Einstein stated that the relative rate of motion between any observer and any ray of light is always the same, 186,000 miles per hour per second. And thus, two observers moving relative to one another, even at the speed of 100,000 miles per second, each measuring the velocity of the same ray of light, would both find it to be moving at 186,000 miles per second, and this apparently anomalously resulted was proved by the Michelson-Morley experiment. According to classic physics, one of the two observers was at rest and the other made an error in his measurement because Lorentz Fitzgerald contraction of his apparatus. According to Einstein, either observer had an equal right to consider himself at rest, and neither had made any error in his measurement. Each observer used a system of coordinates as the frame of reference for his measurements, and these coordinates could be transformed one into the other by mathematical manipulation. The Lorentz transformation, which Einstein adopted, was identical with the classical transformation, except that it contained the vector beta. The speed of light is in variation in any such transformation. Wow. According to the relativistic transformation, not only would lengths of the line of moving objects be altered, but also time and mass. Okay, a clock in relative motion to any observer would seem to be slowed down, and any material object would seem to increase in mass, both as the factor beta, the newly discovered electron QE. We'll go into that, although newly, okay, whatever. Right, so I guess old news provided a means of testing the last assumption, for electrons could easily be accelerated to speeds close to the speed of light. Who would have guessed? So that the value of beta, for example, might be as small as 1/2, and the mass of the electron doubled. The mass of a rapidly moving electron could be easily determined by measuring the curvature produced in its path by a magnetic field. The heavier the electron, the greater the whatever, and the less the curvature produced by a given strength of field. Experimentation dramatically confirmed Einstein's predictions. The electron increased in weight by exactly the amount he predicted. Thus, the kinetic energy used to accelerate the electron had been converted into mass in accordance with the formula E equals mc squared. Energy equals mass and velocity squared. Right? See, atomic energy, we will, but it will probably be censored. Einstein's theory was also verified by experiments on the velocity of light in moving water and by certain experiments on magnetic forces in moving substances. The fundamental hypothesis on which Einstein's theory was based was the non-existence of absolute rest in the universe. Wow. You fucking god. Einstein postulated that two observers moving relative to one another at a constant velocity would observe identically the phenomena of nature. I like me some nature. One of these observers, however, might record two events on distant stars as having occurred simultaneously, while the other observer would find that one had occurred before the other. This disparity is not a real objection to the theory of relativity, because according to that theory, right, simultaneously does not exist for distant events. In other words, it is not possible to specify uniquely the time when an event happens without reference to the place where it happens. Every particle or object in the universe is described by a world line. Ooh, I've seen those before. Right, which describes its position in time and space. if two or more world lines intersect, an event or occurrence takes place. Wow. Ain't that a quinky dink, right? If the world line of a particle does not intersect any other world line, nothing has happened to it, and it is neither important nor meaningful to determine the location of the particle at any given instant. The distance or interval, wow, between any two events can be currently described by means of a combination of space and time, but not by either of these separately. The space-time of four dimensions, three for space and one for time, in which all events in the universe occur, is called the continuum. It doesn't have a QB, but I'm gonna assume it's in the book. It's made out of fancy letters. All of the above statements are consequences of special relativity, a name given to the theory developed by Einstein in 1905 as a result of his consideration of objects moving relative to one another with constant velocity. In 1915, he developed the theory of general relativity, in which he considered objects accelerated with respect to one another. He developed his theory to explain apparent conflicts between the laws of relativity and the laws of gravity. And the law of gravity, well, to resolve these conflicts, he developed an entire new approach on the concept of gravity based on the principle of equivalence. Wow, ain't he a goddamn Elric brother, right? The principle of equivalence holds that forces produced by gravity are in every way equivalent to the force produced by acceleration, so that it is theoretically impossible to distinguish between gravitational and accelerational force by experiment. In the theory of special relativity, Einstein had stated that a person in a closed car rolling on an absolute smooth railroad track could not determine by any conceivable experiment whether he was at rest or in uniform motion. Right? Well, before we get past that, real quick, we still got some more on relativity. Holy shit, relativity is a whole little section. Right? But here's the thing about what this is saying. Don't tell the church, right? Didn't they burn Michelangelo or someone at the stake for saying the world is round? Right? And don't tell the flat earthers that there's math made by a retard that says the world is round. Right? Don't tell those two people. Okay, I'm done with fucking relativity for now, right? I finished the column. We got a couple more columns left. It will be alright. Alright, thank you guys. Have a good one. Alright. I'm gonna try and go have my savage be savage to me again. Oh, my tie is somewhere. I'll find it. Have a good one, guys.